Okay, so today we are going to talk about specific heat capacity. So sometimes we need to compare the energy needed to heat up different substances by 1 degree Celsius. For example, we need to find a substance that we need the least amount of energy. We will have to consider specific heat capacity. What is specific heat capacity? Specific heat capacity of a substance is the energy which is transferred by heating needed to raise the temperature of 1 kg of the substance by 1 degree Celsius. The reason why it's per kg per degree Celsius is because we have to make a fair test. Given the mass and the temperature raised is the same, we have to find which substance is more like an energy waster to change the temperature. To shorten the definition, we can say specific heat capacity is the energy per degree Celsius per kg. The specific heat capacity of water is higher than that of aluminium, so we can actually make things much more clearer by using this as an example. So for water, the specific heat capacity will be 4,200 joule per kg per degrees Celsius. And for aluminium, it's 900 joule per kg per degree Celsius. I think there are some mistakes here that I should add also to the power of -1 instead of just kg here. So we actually have this. Now, because if they have the same mass and the same temperature, so if we just have a look at the specific heat capacity, we can see which one we need more energy to heat the water than that of aluminium, given the same mass and the same temperature. So this is the reason why we say the specific heat capacity is the energy needed per mass per temperature. So if we have a look at here, the water and aluminium, so the mass of water will also be the same with aluminium. The temperature needed to be raised is also the same, but in these two cases, if both of them are the same, that means the energy needed to raise will not be the same. And because the energy needed may not be the same, the time needed may also not be the same. So that's the reason why you need to know how long you have to boil the water, how long you can actually heat the aluminium to 100 degrees Celsius, something like that. Given that we need to raise the temperature for the same amount, and the mass is also the same to make a fair test, we can find out the energy needed is that the water will need more energy because it has a high specific heat capacity. So the higher specific heat capacity, the more energy needed. The lower the specific heat capacity, the less energy is needed. Let's have a look at this. So this would be the general idea of the specific heat capacity. So the energy needed per 1 degree Celsius per 1 kg. So given that's the same amount of mass, the same amount of temperature that needs to be raised, the energy needed will be different because they have different specific heat capacity. It's kind of like how annoying one of the substances are. If it has a high specific heat capacity, it's kind of more like an energy waster. So in fact, to calculate specific heat capacity, we have a formula here. So from the definition, we know that specific heat capacity is the energy per degree Celsius. So I think there's some grammar mistakes here, right here. It should be degree Celsius per kg. So as a result, we can turn it into a formula. So basically, C representing the specific heat capacity. So we have specific heat capacity is C. Okay. Okay, so specific heat capacity is C. Now let me just rub it that. Okay, so Q is the energy. Q is the energy, which means that's the energy needed per mass. So the energy needed per mass. So we put mass here, and we actually can evolve this into something like this. So Q divided by M divided by delta T. So this will be the basic idea, but because we can actually simplify it, so we can just directly write Q divided by M times delta T. So, and T is basically the temperature change we have. For example, if originally it's 20 degrees Celsius, later it is heated to 60 degrees Celsius, then the change in temperature will be 40 degrees Celsius. So this is how we calculate the specific heat capacity. Q, that means the energy needed per mass, so in kg, okay, and delta T in degrees Celsius. So if you have a look at the formula of specific heat capacity again, I hope you remember that it will be C, specific heat capacity equals to the energy denoted by Q divided by mass times delta T, which is the change in temperature. So let's have a look at practice 1. So we need 1,200 joules to heat 1 kilogram of substance X. And we need to raise the temperature by 100 degrees Celsius. So we don't know what is that substance, but we only know the joule and also the temperature. So let's find the specific heat capacity based on this. So if we directly say, oh, it's actually C equals to Q divided by M delta T. So we will just put the formula and put those numbers into the formula after you actually understand what the formula is about. So in this case, don't forget the unit, and the unit will actually be joule per kilogram per degree Celsius. So the answer will be 12 joules per kg per degree Celsius. So if we want to raise the substance X for 1 degrees and 1 kg of that substance X, then we will need 14 joules in order to do so. And let's have a look at a more difficult and challenging question. So an experiment has been carried out to find the specific heat capacity of water, and a geometer is connected to an immersion heater placed inside the water in a cup. And a thermometer is also placed where its bulb is in the middle of the water. So in this kind of question, you may actually draw the setup. So it's kind of like a geometer. So I just draw it like J, and then connected to an immersion heater placed inside a cup of water, and a thermometer is also placed, okay, and its bulb is in the middle of the water. So we can see that the basic idea is something like this, where this will be the water, okay. So let's see. So initial geometry reading, that means originally it's like this, but later on after heating it will be like this. That means the energy that we have used directly. And the temperature raise will be it has been raised by 90 degrees Celsius, and the mass of water will be 0.1 kg. So this contains 0.1 kg of water, okay. And so we need to find the specific heat capacity of water with the experimental results. And we also need to answer why isn't this the same as the standard value, how to improve the accuracy of the experiment, and why does the thermometer reading don't stop directly after switching off the geometer. You must pause the video for you and write your answers on a piece of paper, and we'll check the answer very soon. So here we go, let's check the answer for question 2a first. So we just directly substitute the number into the formula we have, and we actually have 4100 joule per kilograms per degree Celsius. However, the main problem is that there are two possible sources of error. It's not the same as the standard value, which is 4,200 joules per kilogram per degree Celsius, because there are two possible sources of error. First, there's energy loss to the surroundings. Second, the heat capacity of the cup isn't taken into account. So we are just taking into the account of the water inside. But what about this cup? So we also need the energy to raise this water. So this is one of the reasons why this isn't an accurate experiment. So in order to make it a bit more reliable, of course we can't make sure that we find out it exactly, but we can wrap the cup of cotton wool in order to reduce heat loss to the surroundings. That's all that we can do. And the thermometer, the temperature of the heater is still higher than that of water. So this question is talking about why the thermometer still keeps rising, okay, through the temperature. The reason is because there's still heat transfer from the immersion heater to the water, as heat will occur when there's a hotter object, and the heat will be transferred to a cooler object. In that case, the immersion heater, of course, must be greater than that of the water, even though the geometer has been switched off. As a result, we can actually say that there will still be heat transfer, as the temperature of the heater is higher than that of the water.